Okay, now I'm going to share with you how to use the Ampere's law to calculate the magnetic field which is created from an infinite sheet of current. So this will be the theory part in your PowerPoint slide. Okay, so let's say if you have an infinite current sheet, okay, at the location z equals to 0, so this one will be your plane, okay, will be your plane, will be your surface, or will be your sheet, okay, sheet here. Okay, so located at z equals to 0, and at the surface of this plane, so there are current density, uniform current density, which is represented by a symbol K, and this K is flowing in the y direction. Okay, so this one is the case, and you have to find the magnetic field either above, okay, the surface, above the surface, or below the surface. Okay, because this one is an infinite, okay, sheet, so you are not going to find the magnetic field, okay, at the same position, same height, okay, same position or same height of the plane. You can only find the magnetic field up or down. Okay, so if according to the theory part, okay, this one, okay, this is about the derivations. So at the end you will get this formula. Okay, and this formula, if you look at this formula, it is not bold, meaning that this is the magnitude of the magnetic field, meaning that you take the ky and then you divide 2, then you will get the magnitude of the magnetic field. And if you look at this one, this is a bold H, meaning that it is a vector quantity and there are directions. Okay, so you have to look at the locations of your plane and also the direction of your current density in order to determine the directions. Okay, so now I'm going to give you a very simple exercise, just want to refresh you back about how to calculate the magnetic field from infinite surface that carries current density, because I found that there is no written notes, handout or tutorial which I share in Google Drive. Okay, so let's look at this one. Okay, so this is actually a two very simple example how to find the magnetic field. Okay, so let's look at the first one. So you have a plane which is located at the location x equal to 6, and it has current density of 10 and in the y directions, and find the magnetic field at these 2 points. Okay, so the solution will be, first of all, you have to draw your plane. Okay, so please draw your plane. Okay, so this one will be your drawing. You can draw your surface in 3D. So this one will be a 3D, and this one is 2D. Okay, so let's look at a 3D. So you have a plane. So this one is your plane located at locations x equal to 6, and your K is in the y direction. So the blue arrow actually represents the direction of your current density, which is 10. So if you transform it into the 2D, okay, so this one will be your axis x. Okay, and y is actually in the direction coming up from the surface. So okay, that's why I put y and dot here. And look at this one, this is positive y directions. Okay, so all the dot here actually represent the current density which is coming up from the surface, and of course this one will be your axis z. Now let's look at the point that we want to know the magnetic field, 5, 1, 1 and 10, negative 2, negative 8. Okay, so it will be 5, 1, 1. Okay, we go to the 5, 1, 1 first. Okay, first of all, we have to look at where is the 5, 1, 1. Okay, so 5 maybe is here, 1, 1. Okay, z is equals to 1. Why? You are not able to locate the y point in this 2D diagram, so you can only look at the x and also the z. So the x is 5, maybe somewhere here, and the z is 1, so it is here. So this one will be your 5, 1, 1. Okay, another point is 10, negative 2 and negative 8. Okay, let's look at this point. 10, okay, so this one just now is 5, right? Okay, so 10 will be above the plane, so maybe somewhere here 10, and the z is negative 8. So negative 8 may be somewhere here. Okay, negative 8 may be here. Okay, so this one will be the position, okay, of your second point, which is 10, negative 2, and negative 8. So one of the point is located below the plane, okay, 511, and another point is actually located above the plane. So let's look at the formula that we learned. Okay, so this one is the formula that we learned. Okay, this one will be the magnitude of the magnetic field. Okay, so H, okay, will be equals to 1 over 2 K. Okay, so the K given by the question is 10. Okay, it's 10. So the value, the magnitude of the magnetic field will be 5. Okay, but you have to mention about its direction as well. So you can use your right hand to determine the direction of the magnetic field. So all these, they are actually dot. Dot means that the current is flowing out from the surface. So if you use your thumb, you will find that actually your magnetic field is flowing in this direction. Okay, it's flowing in this direction. Okay, so I use different colors. Oh, sorry. Oh, this is not transparent. Okay. Okay, never mind. I will draw it. Okay, so I will draw the direction of your magnetic field. Okay, if you use your right hand, okay, you use your right hand, and you will find that the magnetic field is in the anti-clockwise direction. Okay, because the current is coming out from the surface, okay, the Y. Okay, so at this part, okay, below the plane, you will find that the magnetic field is actually in the positive Z direction, right? Because this one is pointing in the positive Z. So this one, you can write it as 5Z. And amperes per meter will be the unit of the magnetic field. So how about the second point? 10, negative 2, negative 8. Okay, so for the second point, it has the same, okay, magnitude of magnetic field. Okay, so we are also using the same equation, so it will be 5 as well. But how about the direction of this magnetic field? Okay, so if you look at, because this point is located above the plane, so if you look at the portion above the plane, okay, you will see that the magnetic field arrow is actually pointing in the negative Z directions. Okay, negative Z directions. So you will have negative 5 Z. Okay, so this one will be the your magnetic field. Okay. Okay, so this one is based on the right hand's rules. Okay, right hand's rule. You determine the direction of the magnetic field based on your right hand, and then you state it here. Actually, there is another equation that you can use. Okay, by using this equation, you no need to use your right hand to determine the direction of the magnetic field. Okay, so the magnetic field, okay, they actually can be represented by 1 over 2, okay, K, okay, cross product with the unit vector n. Later I will explain to you what is the meaning. Okay, sorry, this one is the vector. Okay, later I will explain to you what is the meaning of this one. Okay, so this one will be the equation. Okay, so let's look at what is the meaning of n. Okay, for the first point, it is here, right? 511, located below the plane. So the n will be the direction actually, okay, from the plane pointing to the point. Okay, so this one will be the normal direction, the plane, okay, pointed to the observation point. Okay, normal direction. So if you look at this arrow is pointing in the downward direction. Downward direction means that it is negative x direction. Am I right? Okay, so if you replace this one for the case, for example, 511, okay, you are going to use this formula, and your h is equals to 1 over 2, and your k, this is a vector, so it will be hand, and you have to insert the magnitude, insert the direction, cross with the N. So if this point, the N will be pointing in the negative X directions. Okay, so it will be negative X directions. Okay, so automatically the magnitude will be 5. So when Y cross product with the X, you will get negative Z, and the negative will multiply with this negative, and at the end you will get positive Z. Okay, so this answer is the same as the answer that we calculated just now. Okay, by using our right hand. Okay, let's look at the second point, which is 10, negative 2, and negative 8. Okay, this point. We are going to use the same equations. Okay, 1 over 2. 10 unit vector Y and cross product with what? Okay, with the unit vector N. Let's look at for the second point. So this one is the second point. Okay, so we have to construct a straight line. Okay, actually from the second point. Okay, and touch the surface, and the angle must be 90 degrees. Okay, so for this one, the arrow is actually pointing in the positive X directions. Okay, so positive X direction. So you will get negative 5 Z in this case. Okay, this is their unit. Okay, so this is the second method for you to determine the direction of the magnetic field. So in the exam, you can pick this method, or you can pick this method. Okay, depends on you. Okay, so this one is a very simple example to calculate the magnetic field from an infinite surface. Let's look at the second questions. Okay, second question. Okay, I'm going to change the question a bit. I don't want to be positive 50. I want to be negative 50. Okay, first of all, you have to draw your plane. If you found that actually this one, right, this one is just for your illustrations. Okay, if you found that actually you don't need this one, okay, you can skip this one, but this one must be correct. Okay, the reason why I draw this one is I want you to imagine, okay, and so that you can label the axis here. Okay, so for the second questions, you can try to draw again your surface. Okay, so this one will be a drawing. Okay, look at the questions. The plane is located at y equals to 0. So y equals to 0 is here. Okay, and the k is negative 50 z direction. Okay, so it is pointing downward. And if you transform this 3D into 2D, so this one will be the diagram. Okay, so this diagram is constructed by assuming that you look at this plane from this side. Okay, so y will be here, x will be on the right. Okay, and the positive z will be pointing out. Okay, from the surface, but the current density is in the negative z direction. Okay, you must always compare these two things. Okay, so you cannot simply actually assume this one is negative x or z or whatever. Okay, you have to always refer to this 3D. Okay, so let's look at how we calculate the magnetic field. So what points do you have? So 2, negative 1, and 5, and the second point is negative 4, 1, and 7. Okay, so these are the points. Okay, let's look at this point. So this is y and x, so we are looking at the x and y only. Okay, so the x will be 2, y will be negative 1, so it is somewhere here. For the first point, 2, negative 1, and 5. Okay, for example here. Okay, another one is negative 4, 1. Negative 4 is here. Okay, 1 is here. Okay, again 1 up and another down. Okay, negative 4, 1, and 7. Okay, so let's look at the magnetic field of the first point. Okay, the first point. So H equals to, I will use the formula. Okay, in this case I will use the formula. Okay, cross product with the N. Okay, so let's look at where is the end. So this is the point. So you have to construct a line, straight line, 90 degrees. Okay, and your arrow is pointing in the negative y direction. Okay, so this one will be 1/2. Okay, 1/2, and this one is negative 50 z, right? Cross product with the just now is negative y, right? So you will get 25, and the zy you will get negative, you get positive, zy you will get negative x. Okay, now let's look at the second method, okay, to determine the magnetic field. Okay, so from this one, okay, if you remember, okay, let's calculate its magnitude first. Okay, so the magnitude will be 1/2. Okay, multiply with what? This is negative 50 z, am I right? But you cannot take this negative, you can only take this 50. Okay, 50 is the value. Okay, don't insert the negative because the negative belongs to directions. Okay, so you will get 25 also. Okay, let's look at the directions by using our right hand rules. Okay, so I will construct this one will be the directions of the magnetic field, and the current is going in. So going in, it means that it will be in this direction, right? Okay, so it will be in the clockwise directions. So for this point, the magnetic field is in the negative x direction. See? So you will just top up negative x here. Okay? Sorry. So maybe here I will use, and this one will be this one. Okay? So you see, two methods will give you the same answer. Okay, let's look at the second point. Okay, so this one will be 1/2 k with the unit vector n, and for this point, the unit vector n is pointing in the positive y directions. So it will be 1/2. Okay, you have to insert the negative z, and you cross with the positive y. So zy you will get negative x, and balance out with this negative you will get positive answer. Okay, so we will use the second method using our right hands. 1/2, still 50. Okay, don't insert the negative, so the magnitude will be 25. And how about its directions? Okay, above the plane, the direction will be in the positive x directions. Okay, so you will get same answer. So these two are very simple examples on how you use the right hand, okay, and also the equation here, okay, to determine the magnitude of the magnetic field. Okay, I think the most important things is you must draw the diagram, the 3D diagram and also the 2D diagram correctly. If you draw this diagram wrong, of course you will get wrong direction. Maybe you will get a value correctly, but you won't get the correct directions. Okay, so be careful when you draw this one. So I hope these two examples can make you understand more about how to calculate the surface, the magnetic field generated from the surface current. So I will share this video as well as this handout in the Google Drive. Thank you.